Now for the fun part. Let's use these three rules. Bottom heavy is the best. Our answer is 0. Equal, we're going to write the ratio, the fraction of the leading coefficients, the numbers next to the highest power. And then top heavy is the hardest. We're going to divide every term by x to the highest power in the denominator to see if it's positive or negative infinity. So let's look at this first example. We have the limit as x goes to infinity. That's super important. If this was x going to a number, we wouldn't use this at all. If it's x going to 6, don't forget all the work we just did with limits. If it's x going to 6, x going to -5, if it's x going to a number, we would plug in factor and then make a table if we had to. But because it's x going to infinity, then we get to think bottom heavy, equal, or top heavy. So because it's x going to infinity, we're thinking bottom heavy, equal, or top heavy. Two completely different methods. If it's the limit as x goes to c, that's a hard one, plug in, factor table, and then x going to infinity, those are a little bit nicer, bottom heavy, equal, or top heavy. So this one, it's x going to infinity. So what's the degree of the top? And let's write these in, just so we have them in our notes when we go to study for the test or the final. The degree of the top and the bottom we'll write in here. We have n for the numerator, the degree of the top, and d for the degree of the bottom. So 27x, the degree of the numerator is 1, because it's just a regular x. The degree of the denominator is also 1, because you have 3x minus 5. So what case do we have? We have equal. The degree of the numerator is the same as the degree of the denominator. So my answer is going to be the ratio of leading coefficients. Make a fraction out of the numbers next to x to the highest power. So in the top, I have 27. So there's the top of my fraction. In the bottom, the number next to x to the highest power. Be super careful on this. It's not 3, it's -3. So my answer is going to be 27 over -3, which 27 divided by -3 is -9. You do not have to simplify in this class. Either answer is totally fine, but you'll see these on multiple choice a lot, so I would look for -9. I'd probably simplify that one. Okay, we just solved our first limit at infinity. Let's do it again. So in the next one, I'm going to look at the degree of the numerator, the degree of the denominator, and try to make a decision based on it. So the degree of the numerator is 1, and the degree of the denominator, -3x squared minus 5, the highest power of x in the denominator is 2. And again, the only reason I'm doing this is because of the limit at infinity. If it was x going to 4, I'd plug in, factor, make a table. But the degree of the numerator is 1, the degree of the denominator is 2. So is this bottom heavy, equal, or top heavy? This is bottom heavy. The degree of the denominator is higher than the degree of the numerator. Bottom heavy is absolute best. The answer is 0. We're all done. All right. Our example 3 next. We have the limit as x goes to infinity. So I'm thinking bottom heavy, equal, or top heavy. And I'm going to compare the degree of the numerator to the degree of the denominator. This is not necessary work to show your answer, but it'll help you when you're studying. So what's the degree of the numerator? 27x squared. The highest power is 2. In the denominator, -3x minus 5. The degree, the highest power in the denominator is just regular x, which means it's to the first. So what case is this? Top heavy. Unfortunately, the degree of the numerator is higher. So this one is the one where we have to do some work on it. We're going to divide every single term by x to the highest power in the denominator. So we're going to take the limit as x goes to infinity still going to positive infinity, and we're going to take every single term and divide it by the highest power of x in the denominator. So the highest power of x in the denominator is just a regular x for this one. So we don't want to take the coefficient with us. We don't want to divide everything by -3x, because that just makes it a little bit harder to do. So we're just going to take our regular x. 27x squared gets divided by x. In the bottom, we have -3x. That's going to get divided by x. We have -5, and that's going to be divided by x. Every single term gets divided by x. And now we're left to simplify what's left. So So we're still going to have the limit as x goes to infinity. And in the top, 27x squared divided by x. These x's cancel, and you still have an x up top. So you're left with 27x. And you could think of it from our first page, 2 minus 1 is going to be 1. When you divide bases, you subtract their exponents. What about negative 3x divided by x? Those x's will just cancel perfectly, and you're left with negative 3. And then negative 5 divided by x. There's nothing to cancel there. But this one is nice because, what is it? It's bottom heavy. Negative 5 divided by x. Let's think about this in real life terms. So if I brought in 5 cookies and I said we're going to split up these 5 cookies evenly with every single student at Coastal. So we're going to take 5 cookies and we're going to divide it up into about 10,000 students. If I had 5 cookies to divide by 10,000, which is not even close to infinity, how much cookie would you get a bite of? Basically nothing. You'd get a crumb if you divided 5 cookies by 10,000, if even. You probably wouldn't even be able to taste it. So anything bottom heavy like this is going to go to 0 as x goes to infinity. 5 is not enough to divide by infinity. It's not even enough to divide 5 cookies by 10,000. So anything bottom heavy is just going to go to 0. So how I normally do this is I divide everything by x, and then I cross out bottom heavy ones before I even start simplifying. But either way is totally fine. So after you simplify what's left by canceling out x's and getting rid of what's bottom heavy, now you plug in infinity. Is the final answer positive infinity or negative infinity? It has to be one or the other. So I'm going to plug in 27 times infinity divided by negative 3. 27 times infinity is going to stay way up at infinity. You can't get bigger than infinity, so we'll just call that infinity. And then divide infinity by negative 3, you're still going to be way up at infinity. Even if you had to divide your billions of dollars up by 3, you would still have billions of dollars. You'd still be way up at infinity. So it's not really whether you're at infinity still or not. It's are you at positive infinity or negative infinity now. So 27 times infinity is infinity. Divided by negative 3, positive divided by a negative is it's going to make it negative infinity for our final answer. So we knew it was going to be positive or negative infinity. You can't get any bigger than infinity, and even dividing it by something, you stay way up at infinity. So it's just whether it's positive or negative. Okay, there's one of each type. So let's see some more on the next page. So this next one, we want to think about what case do we have. So we have the limit as x goes to negative infinity. So we're not going to plug in, factor, or do a table. We're thinking top heavy, bottom heavy, or equal. So for this one, we have x to the 5th minus 3x squared over x to the 4th plus 1. So what's the degree of the numerator? It's 5. The highest power of x is 5 in the numerator. And in the denominator, the highest power of x is 4. So is this top heavy, bottom heavy, or equal? This is top heavy. It's our worst case scenario, but our answer is infinity or negative infinity. Let's see which one it is. So we're going to take the limit as x goes to negative infinity still, and we're going to take every single term and divide it by the highest power of x in the denominator. So this one we're going to divide by x to the 4th. Remember, we wouldn't take the coefficient with us if there was one, like last time we didn't take the negative 3. So here we're just going to divide by x to the 4th. So we're going to have x to the 5th divided by x to the 4th. We're going to have minus 3x squared divided by x to the 4th. We're taking every single term and dividing it by x to the highest power in the denominator. So in the denominator, we have x to the 4th divided by x to the 4th plus 1 divided by x to the 4th. So now before I simplify by each term like I did last time, I'm going to go in a different order because this is the order I prefer. You can do either one and you should get the right answer. Before I even simplify what's left, I try to get rid of what's bottom heavy because that's just going to go to 0 anyway. So is x to the 5th over x to the 4th bottom heavy? No. But x squared over x to the 4th, this bottom degree is higher. So this is bottom heavy. It's just going to go to 0. That's nice. I can get rid of that. Is there a bottom heavy term in the denominator? Yes. If I brought in 1 cookie, we'd be even in more trouble. 1 divided by infinity to the 4th or negative infinity to the 4th, you're not going to have anything left to give. So there's our 2 bottom heavy pieces. And now we're going to simplify what's left. The limit as x goes to negative infinity And we have x to the fifth over x to the fourth. Remember, dividing powers, or dividing bases, means we're going to subtract powers. So x to the fifth minus 4 is just going to be x to the first. 5 minus 4 is 1 through my new power of x. And then x to the fourth over x to the fourth just simplifies to be 1. So now I can plug in. I'm going to have negative infinity divided by 1. So what's my final answer? Is it going to be positive infinity or negative infinity? It's going to be negative infinity. Okay, so now we've done two top heavies, one bottom heavy, and one equal. So try these last 3 on your own. See if you can get any of those 3. Some of them are easier than others. And then check back in the next video to see that you have the answers right.